all of you. Uh, I'm going to take your computational science engineering problem solving sessions every week. So, you know what we are going to do. We are going to do problems, whichever the concepts taught in your week, right? Okay. So, can anyone tell me what are the things are taught in this week 1? Like, I'm just noting down vector space, right? Is vector space is taught? You can also reply in chat. Okay, you can reply in chat or audio, anything will work. So vector space, then yeah, null space means like fundamental subspaces of vector space, right? Then you must have heard about column space, row space, right? Then uh, so we will solve some problem to understand these concepts. Okay. Okay. First of all, I will just revise for you. If we have some A matrix having dimension m cross n. Okay. So if you want to find out the dimension of column space of A, so does anybody know what are the dimension of column space of A? Yes. Anyone? Uh, Hello guys, are you able
Sir,
to
is it
hear?
n itself, sir?
Huh?
Is it n itself, dimension of column matrix of it?
Dimension of column space of A. Okay. 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 See, these are row number of rows and number of columns. Okay. It will have some rank, right? Which is R, right? So what is the dimension of column space of A? It is R, right? Okay. R is the rank of the matrix A m cross n. So dimension of column space of A is R. Okay. Similarly, uh, we have dimension of null space of A. Okay. Null space of A dimensions are so okay n minus R. Okay. And dimensions of left null space of A. Left null space. What do you mean by left null space? Left null space is the this is null space of A transpose, right? Which is M minus R. Okay. So these things must have been taught to you. Okay. So even before this, we go to some fundamental things. Okay. How to find null space of any matrix? What we do? What we do? If we have a matrix and x is the coefficient matrix of the variable, so how will you find a null space? Null space is such that you will get the homogeneous equation, right? Means it will be the vector x such that it will, on the multiplication of a, it will give zero vector, right? Are you following, guys?
Yes, sir.
Okay, so this concept is clear, right? Second thing, so we will understand this with the help of problems. Okay, before that, what is vector space? Vector space is what? It is a bunch of vectors such that, oh sorry, it is bunch of vectors such that all the vectors are closed in addition and linear combination. Okay, this is, we can define the vector space in this way. So, like for example, we have uh, say vector space consisting of vectors v1, v2, v3, dot 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 vn. Okay, so uh, we def we can say this vector form a specific vector space only when uh, this v1 plus v2 or v1 plus v3, v1 plus v2 plus v3, or cv1 plus say wv2 are all element of that vector space. Okay, is it clear? Yes, people, is it clear?
Sir, could you repeat once again, sir?
See, if this belongs to some vector space, okay, so how you ensure it is belonging to vector space? If v1, v2, v3, dot 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 vn, we have n vectors and belonging to some vector space Rn. Okay, so how will you like how will you say define this vector space, or whether these vectors are in that particular vector space R raised to n? So it will be only when these two conditions, okay, that the sum of any of these vectors or the linear combination of the sum, that is, if you multiply by some scalar c with particular vector plus the scale multiplying some other scalar with other vector, it should remain in that vector space. For example, what we can take, so suppose we have some vector, okay, uh, say 1 comma 1. Okay, so this vector, and this is the your vector space, the entire is your vector space, all four coordinate. Okay, okay, now if you multiply it with any scalar, say multiply by 3, so it will lie on this same line, so 3 comma 3, right, and it is still in this vector space, right? Even if you multiply it by minus 3 comma, means minus 1 minus 3, so it will be minus 3 comma minus 3, still it is in this space, right, right. So you multiply by any scalar, it will remain in this all four coordinate, which is the vector space of real values, right? So it's denoted by R. So if any of this addition or multiplication with the scalars, if it is remain in that vector space, then those vector and in that particular vector space of real values. Okay. Now is it understood?
Got it, sir.
Okay.
Sir, the second formula, CV1 plus WV2 and to the power epsilon and something, sir. What is that, sir?
What epsilon? Epsilon is
Sir, the
element
one
of
which you wrote now.
element or belonging to
Yes,
that
sir.
vector space. Like I will rewrite it.
Got it, sir. Now,
You understood or not?
now I got it, sir. Yes, sir. Now I got it, sir. Yes, sir.
This actually belonging to vector space. Okay. If this belongs to vector space, addition and scalar linear combinations are also belonging to our vector space R, then all vectors are in the vector space R. Okay. So
Yes, sir.
okay. So we will understand some column spaces or some this year, what do we say, row spaces with the help of the example, because it will be very clear with the example. Okay, so what okay, before going to that, what are the four fundamental subspaces? What are the four fundamental subspaces? You must be learned this in the first week, right? What are the four fundamental subspaces? Anyone? Yes. What are the four fundamental subspaces? Four fundamental subspaces are column space, of a matrix say A, then null space, then your column space of A transpose, and null space of A transpose, also called as that left null space, left column space, right? These are the four fundamental subspaces. Okay, so let's take some examples. So first example, find null space, row space, and column space of matrix A, where A is 1, 2, 3, 2, 3, 0, 1, 8, 2, minus 2, minus 2, 6. Okay, what is the order? Yes, what is the order? Order of the matrix. What is the order of the matrix?
3 cross 5, sir.
3 cross?
5. Sorry, sir. 4. 4. 4.
Yes, 3 cross 4. Okay. Okay. So what we do first? Reduce echelon form, right? So just tell me how to reduce this matrices. What are operations we have to conduct?
Row transformation, sir.
Yes, yes. What row transformation? Yes. What are the row transformation? We have to make this 0, right?
Yes,
So R2 minus 3R1, correct? Are you following, guys?
yes, sir.
R3 minus 2R1, correct?
Yes, sir.
So what you will get? What you will get? Give me the second and third row.
Minus 6 on the first R2, sir.
Okay, okay. Minus 6, yes, correct.
And minus 8 on the second one,
Okay,
beside
minus
12.
8, okay. Then,
And plus 2 on the beside to 8, sir.
okay, correct, correct. Then, minus 2, minus 4, minus 6 again, right? Minus 2, minus 6, minus 8 again, correct? And 6 minus 4, 2. Okay, then what we will do?
So we could add both R C. We couldn't do column matrix, no, sir, like in row
So you
transformations.
you do 0, 0, yes. Again, you have to, uh, what you will do, just R3 gives R3 plus R2, right? You have to make this 0 now, right?
Yes, sir.
So R3 gives R3 plus R2, right? So what you will get, right? So what are the pivot elements? Can you tell me what are the pivot elements? Yes, Sumukha, can you tell me what are the pivot elements? Sumukha, are you there?
Yes, sir.
Yes, what are the pivot
But
elements?
I don't know.
What?
I don't know, sir.
You don't know? Okay. Uh, Whenever we get a row echelon form, so pivot element are the first element in the non-zero rows, right? So what are the first element in, what are the two non-zero rows?
Row 1 and row 2.
So what are the pivot element here?
1 and minus 6.
1 and minus 6, correct? Okay. So this, whatever this uh, pivot element, this will form your basis vector, okay? And remaining two are, means this you can say consist of x1, x2, x3, x4 column vectors, right? So x1 and x2 will form your basis vector, and x3 and x4 will be your free variables, right? Right?
Yes, sir. Sir, could you repeat on pivot elements once again, sir? I couldn't get that one.
See, the columns in this pivot element will form your basis vector, okay?
Yes, sir.
And as
Sir, how do we choose that pivot element, sir? You told non-zeros term
because
something,
we are
but
what non-zero means like this is the we are trying to diagonalize this thing, right? Upper triangular. So whatever are on the
yes,
diagonal,
sir.
but this is not a perfect square matrix, right? So
Yes, sir.
whatever comes on the diagonal, this is imperfect diagonal. Still, first element on that diagonal will be the your pivot.
Got it, sir. Yes,
Did you get what I am trying to say?
yes, sir. We don't have a proper diagonal here, so we are taking the first element as the diagonal thing.
Right? And this pivot will form your basis vector. Means the column vectors corresponding to the pivot element will form the basis vector, and this will be the your free variable. Okay. So you got the free variable. So if we try to write the equation, x1 plus 2x2 plus 3x3 plus 2x4 is 0. For why I have taken this 0? If I am taking this is equal to 0, then what I am trying to do? We have just now revised the concept of null space, right? If you want to find a null space, you have to find x such that a into x should get 0 vector, right? Right?
Yes, sir.
Perumal Swami, is it unclear to you? Perumal Swami, are you there? Sumukha, is it clear to you?
Yes, sir.
Okay, so this is like you are taking ax is equal to 0, so this is equal to 0 to find null space, correct? Okay, so what will be the second equation? Yes, what will be the second equation?
Minus 6 of x2 and minus 8 of x3 and plus 2 of x4 is equals to 0, sir.
Okay, so what we do in free variables, we have to assume the values, right? Because those are forming this independent variables, right? We have rank. Okay, what will be the rank of this matrix? Do you know how to find the rank?
Sir, 1 is the rank, sir, for this one.
No, no, no. Rank of the matrix is number of non-zero rows. Okay, the rank of this A is number of non-zero rows. How many number of non-zero rows?
2.
2. So rank is 2. Correct? We got R is equal to 2. Just okay. So you got rank is equal to 2. Before going to this, we will just guess uh, what will be the dimension of null space, right? We can judge dimension of null space based on this formula, right? People, is it very are you finding difficulty in understanding?
Sir, rank of the matrix, sir.
Rank of the matrix, okay. Rank of the matrix is number of non-zero rows in that matrix. So there are two non-zero rows. After getting row echelon form, we are getting two non-zero rows, right?
Sir, but there is only one row which is not having any zero. So is it? It should have been one, no, sir.
No. Rank of the matrix is number of non-zero rows. Number of non-zero rows. Here rank is 2. Okay. It
Sir,
is
could
not
you show which are those two non-zero rows?
R1 and R2. Are the all elements 0 in R1 and R2?
Sir, non-zero means the entire thing shouldn't be zero, sir.
Yes. And all elements of the rows are 0, then it is 0 row. If all elements are not 0, then it is non-zero row, right?
O- Okay, sir. Now I got it. I thought there shouldn't be a single zero also in that. So got it, sir.
No. The entire row should not be 0.
Got it, sir. Clear, sir.
Okay, now is it clear to everyone? Yes, Sumuka, did you understand the how the rank is 2 for this matrix?
Yes, sir.
Okay. Okay, so we can just the dimension based on the formula. Dimension of null space of A is n minus r. What is n here?
4.
4. What is r here?
2.
2. R is rank, right? So dimension will be 2. So there will be two vectors in the null space of A, right? So we will find out. Okay. So in the finding out the process, okay, this is just we are guessing. Okay. Now we will again come to this equation. Okay. So we have what are the free variables here?
X3 and X4.
X3 and X4. So what we do, we put X3 as 1, X4 as 0 first. Then we will put X4 as 1 and X3 as 0. Okay. So when we put X3 as 1 and X4 as 0 in equation A and equation B, so what are the values we get for X1 and X2? Yes. Hello.
Sorry, X2 is minus 1 by 3.
X2 is
Minus 1 by 3.
X2 is minus 1 by 3.
No, just 1 by 3.
Minus 4 by 3, I guess. First you will put x3 is equal to 1 and x4 is equal to 0 in equation A and B to get x1 and x2. Yes.
Sir, x1 is 1 by 3
X1 is 1
and
by
x2 is
3. Yes, and x2.
4 by 3.
Are you sure?
So minus 4 by 3 or 4?
Let's check. Okay, so we put x3 1 and x4 0. So minus x2 is equal to 8. So x2 is 8 by 6, 8 by minus 6, right? So it is minus 4 by 3, right? Okay, right? And x1 is,
Yes, sir.
from 1 we will get x1, right? x1 plus 2x2. So 2 minus 4 by 3, and x3 is 1. So 3 is equal to 0, right? So x1 we get 9 minus 8 by 3, 1 by 3. So x1 is minus 1 by 3, correct?
Yes, sir.
You got x2 and x1 for
Yes, sir.
x3 free variable, right?
Yes.
Similarly, we will calculate x1 and x2 for x4 free variable. We have two variables, free variables. So we will calculate values of basis variables for each free variable. So what we will do, we first take x3, put x3 1 and other free variable 0, and then same we will repeat for the x4, correct? Is it clear?
Sir, can you repeat?
There are two free variables, right? x3 and x4. Okay, and we have to represent this basis variable in x3 and x4, right? So one time we will take x3 1 and x4 0 and find out values of x1 and x2 for x3. Okay,
Yes, sir.
then same thing we will do for x4. What we will do for x4, we put x4 1, x3 0 and calculate x4 1 and x3 0 for x1 and x2, correct?
Okay.
Chandan, is it clear?
Yes, sir.
Okay, so can you calculate for x4 variable?
Sir, x2 is 1 by 3.
X2 is 1 by 2. Okay, x2 is 1 by 2,
1 by 3, sir.
1 by 3. Okay, and x4, oh sorry, x1,
Minus 8 by 3.
can you please recalculate? Okay, it is minus 8 by 3, correct? Minus 8 by 3, correct? So what will be the null space? In the form of variables this. So for x3 what we got? x1 value minus 1 by 3, x2 value minus 4 by 3, and this is 0, correct? For x4 you got x1 value, x2 value, x3 value, x4 value, correct? Is it clear?
Yes, sir.
So what is the dimension of your null space, or how we give the null space? How many vectors are there? How many vectors
Four
are there?
vectors. Oh, two.
Two, right? Right?
Yes.
Is it means whatever we have deduced earlier, is it correct?
Yes, sir.
Yes, Chandan. Is it clear?
Yes, sir. Yes.
Okay. Now row space of A will be your these two matrix, non-zero matrix. This will be your row space. Wait a second. Sorry, your row space will be this. The basis vector will be your row space. Okay. So sorry. Wait. Wait. My mistake. We are calculating column space, right? So your column space will be their basis vector. You calculate null space based on free variables. You will calculate your column space based on basis vector. So what will be the column space? 10, your column space will be 13220 minus 2. Okay. Is it clear?
The
Is it
column space once again, sir.
column space? See, what are the basis vector variables x1 and x2, right? We are saying
Yes, sir.
column wise. Okay. So these calculation are for null space. You calculate null space based on free variables, right? Then the rest of the variables which are there, those columns are your column space of your original matrix, not this calculation. Is it clear?
Sir, how to choose X1 and X2 itself, sir? Like we had other two matrices also. Like,
Other two columns. So how we chose that based on pivot, right?
yes, sir. So the basis vector becomes the column matrix,
Column
column
space.
space.
Yes.
Yes, got it,
Column
sir.
space. Okay. Is it clear?
Yes, sir.
And the row space of A will be your, what will be the row space? Do you have any idea about what will be the row space? Row space will be exactly your reversal of your this thing, or you can say row space will be this thing, 1 2 1 2 3 2. You can write. Yes, row space will be, okay. What will be the dimension of row space? Do you have any idea about it? It will be same as your null space, right? And we got the null space. You just, those are a column. You have to just flip that null space and you will get the row space. So what will be the row space? 0, 1 minus 4 by 3 minus 1 by 3, 1, 0, 1 by 3 minus 8 by 3. Is it clear?
Yes,
Yes.
sir.
How did you got a row space?
Sir, by just inverting the null space, sir.
And column space, the original, where you on which you find the basis vector, right? Right?
Yes, sir.
Yes.
Okay, it is clear, right? You we will so it will be more clear when we solve some more problems. Okay, so question 2, we have say a matrix 1 0 minus 2 6 minus 3 6 6 minus 6 2 minus 3 minus 4 6. Okay, our aim is to find set of vectors that span null space of A. Means we have to find out the dimension of null space, that is span of the null space and null space of A. Okay, you know how to find out the null space of A, right? Now how will you find out the null space of A? First, what you
So
will do?
first we'll do transformations.
You will do reduce row echelon form, right? 1 0 0. So in transformations, when you try to do the transformations, so what we try to do is, what we try to do, we have matrix, we try to diagonalize it keeping these zeros, correct? Right?
Yes, sir.
And this diagonal element will be what?
Pivot.
Correct, correct. So here to make this second row 0, what you will do? To make second row 0, we have to do R2 plus 3R1, correct?
Yes, sir.
And third row
R3 minus 2 R1.
2R1, right? Okay. Okay, what will be the rest of the these things? This will be 6, this will be 6 plus 6 minus 6 plus 18, it will be 12, right? Then R3, this will be minus 3 minus 4 minus 4 minus of minus 4, so it will be 0, and 6 minus 12 will be 6 minus 12 will be minus 6, right? So is it, are you following, guys?
Yes, sir.
Someone is joining. Okay, you're following, right? Correct. So
Yes, sir.
uh, what will be our the matrix after this? What we will do? We will make this 0, right? So what operation you will use? What operation you will use? Yes, people.
R3 equal to
R3 gives R3. Yes, R3
Twice of
gives
R2, sir.
plus twice of R2, correct? So what you will get, right? What is the rank of the matrix A?
2, sir.
2, correct. Then okay, what are the free variables here?
sir.
Yes,
So in the last transformation,
Hmm?
shouldn't it be twice of R3 plus R2 should be the last row as 0?
Yes, tell me what?
You said in this last transformation from -3 and -6 to 0,
Hmm?
it should be R3 gives twice of R3 plus R2, sir.
Sorry, sorry. Yes. Or you can write this, correct? Is it correct? Generally,
Yes,
you
sir.
don't do this, like, you don't take multiple in the same row, okay? Because it will
Okay,
create confusion.
okay,
Means when you solve more problems, no, you will experience that thing, okay? So generally try to do the operation on the next row. Like, you are getting my point, right?
yes, sir.
Okay. So what are the number of independent variables, and what independence variable are? So this is, say, x1, x2, x3, x4. Yes, tell me. What are the free variables and how many of them? How many of them?
For two free variables and two independent, sorry, basis variables, sir.
Okay, so basis variables are two. Independent, what are those?
Sir, first x1 and x2 are basis variables, and
X3
x3
and
and
x4.
x4 are
Correct,
independent variables.
correct, correct. Right. So you know the procedure to find null space, right? What you will do? First, you have to represent null space in terms of free variables, right? That is in terms of x3 and x4. So what you will do, right? You will get two equations here. So what are those two equations? We will write separately. Why it is 0? You know these things. Should I use some other color?
No problem, sir.
No, it will be more easier, right? Okay. Okay. So your first equation is this. Second equation is this. Why it is 0? Why it is 0? We are
So
trying
null space.
we are trying to find null space, right? Correct? So if you put
Yes.
x3 is equal to 1 and x4 is equal to 0, what will be the values of x2 and x1?
X2 equals 0 and x1 equals
x1 is equal to
2.
2, correct? Then you have to find for x4, right? You have to find for x4 also, right? Right? Are you guys following?
Yes, sir.
Yes, sir.
Okay. Find out for x4.
X1 equals -6.
x1 is equal to -6. Okay.
X2 is equal to
x2 is equal to,
2.
are you correct? Means, are you sure?
So 1 by 3, sir. I mean minus 1 by 3 x2.
How x2 is 1 minus 1 by 3?
Sir,
We have
minus
6x2. Sorry, sir, it's 12. Sorry, I mistaken.
Okay, x2 will be what?
minus 2.
Minus 2, correct. Correct. Good. So what will be the this null space? Give me the null space. It will be in the terms of x3 and x4, right?
Yes. Yes.
Actually, there is fest going on in our college, so that's why there is some background noise. So yes, tell me. Correct. So what is
Yes, sir.
the your dimension? 2, right? We write null space like this, and you are asked to write the null space. Write null space like this. Okay, that is your span also, right? So we will recheck it. What is the rank? What is the n value?
4,
4. What is m value?
3,
What is rank value?
2.
Okay. What will be the dimension of null space of A transpose? What will be the dimension of null space of A transpose?
4 minus 2, sir.
Dimension. I what I have just see what I have written. What is the dimension of left null space? Null space of A transpose.
Okay, sir. Then it
Yes, it is m minus r, right? Right.
yes, sir.
Yes, sir.
So what it will be?
Same.
Okay. What is same for null space of A? 2,
2, sir.
right? What will be for the column space of A transpose?
2, sir.
And for column space of A?
Same 2, I guess, sir.
Right. Correct. You understood this
Sir, the
concept?
rank of matrix for dimension of AT and sorry, means column matrix of
A
AT
transpose
and
and
column
A
matrix of.
are same, yes. Okay, these
Okay, sir.
all
Got it.
rules are applicable when condition of applicability, when your rank is less than equal to M and rank is less than equal to N. Is it so here? Is rank is less than both M and N?
Yes, sir.
Hmm?
Yes, sir.
Are you following, guys? What I am trying to say? What I am asking? Are you following?
Yes, sir.
Yes, sir.
So we will check whether a particular vector is in the null space of A or not. Okay. So how will you find this? What will be your approach? What will be the approach? Yes, anyone?
The transformation.
No, no, no. You are what is the question? Question is x vector is in the null space of A.
Sir, we could multiply A into X to find zero null
Right.
matrix
Whether
or
we will
something.
check whether A into X is zero vector or not, right? So do you
Yes,
know
sir.
you guys know the matrix multiplication, right?
Yes, sir.
So please can you calculate what will be the answer? What is the answer? Okay, sorry, my mistake. Okay. Yes, what is the answer? So minus 2, 3, 13, 26. 26 plus 36 minus 26 plus 36, 10 minus 10 is 0, right? And 26 plus 24 is 50. 50 minus 50 is again 0. And minus 52 plus 12. Minus 52 plus 12 is minus 40. Plus 40 is 0, right? Yes, guys, are you getting the 0 vector?
Yes, sir.
So is it in the null space?
Yes, sir. It is in null space.
Okay. So again, further concepts. You are finding difficulty in hearing my voice? Are you finding the difficulty?
No, sir. We could manage.
Okay.
No, sir.
Because here is actually the face, no? That's why there are some background noise, okay? So, so do you know the permutation matrix, right? You know the permutation matrix? So if I have, I want nth order permutation matrix, nth order matrix. So how many permutations are possible? How many permutation matrix are possible here?
N permutation, sir.
Any other? Any other view of any other person? How many nth order matrix are possible? Permutation matrix.
In factory.
N factorial, correct? It is n factorial. Please remember this. Okay. Okay. If I have a matrix, okay, I have this matrix. Sorry, I have this matrix. Okay, and say I have permutation matrix. If I do P into A, what will be the result? What will be the result? What I am doing here? What I am doing here? Yes.
Sir, it's not clear. So like from what is P into A, from there
P
I
into A.
guess
Okay, what is P into A? Okay, I am multiplying P on the left hand side. So when I multiply permutation matrix on the left hand side, what it will do? It will only, what it will do? It will change the row, right? So what will be the result? Is this concept clear? Is this concept clear?
no, sir.
Whenever you multiply permutation matrix on the left of the matrix A, it will change the row. So initially what was the rows? A, B and C, D, right? So has rows been changed? So C, D and A, B, right?
Got it, sir.
This concept you must have been taught, right? Similarly, if I do this, right hand side multiplication, what it does? It changes
column.
column. Okay. So what will be the result? What will be the result?
BD, uh, BUD.
Right? Are this concept clear? This is clear, right? Okay. Now earlier we have found out the row echelon form. So if I ask you the question, if I ask you, uh, I'm asking you, if A is 5 by 5 matrix, A is 5 by 5 matrix, so what will be the operations required to convert A to L, that is lower triangular matrix? Yes, you have A 5 by 5 means there will be 1 1, 1 2, 1 3, 1 4, 1 5, 2 1, 2 2, 2 3, 2 4, 2 5, 3 1, 3 2, 3 3, 3 4, 3 5. Right? Are you guys following me?
Yes, sir.
Okay. So 4 1, 4 2, 4 3, 4 4, 4 5, and 5 1, 5 2, 5 3, 5 4, 5. Yes. Tell me, if you want to do row echelon form, right? So what you have to do? You have to make all these 1, rest of this 0, and these are pivot, correct? So you need, what you need, 1 to 2, you need 2 1, 3 1 3 2, 4 1 4 2 4 3, 5 1 5 2 5 3 5 4, right? To be 0, right?
Yes, sir.
So to make this, you have, how you will get upper triangular matrix? Oh, sorry, convert to the lower triangular matrix now. Upper triangular matrix. Okay. So I have to make this 0, so we have to do these operations, right? Just observe, just observe what I am writing. Okay. Whatever you have to make 0, you have to do that operation. So E21, you will write that operation as E21, then E31, 32, E41, E42, E43, E51, E52, E53, E54. Okay. Okay. So finally, A will be what? Times U. So inverse of this thing, right? The whole thing. Hello.
Yes, sir.
Wait a second. I just confirm this thing because these are very important concepts. I have actually written this. So are you able to see this, right? So this is
Yes, sir. Visible, sir.
visible, right? Okay. So see this thing. 213132. Okay, you have to write from the inner. Okay, inner side. Okay, slight change, slight change. That's what was my confusion actually. Okay, so because the order matters here. Okay, so order is very important. Order in which you are multiplying the matrices is very important. Okay, so you will go from innermost to outermost. So E21, E31, E32. You guys are getting right what I am trying to say.
Yes, sir.
Okay, so if they told you write it in terms of u, so what you will do, you will just take the inverse of whole thing and multiply by u. So what will be the inverse? What will be the inverse? What will be the inverse? Inverse of this whole term, this whole term inverse. What will be the inverse of this whole term? If I am writing a into b into c inverse, so result will be c inverse, b inverse, a inverse in reverse order, right? Yes.
Yes,
Are
sir.
you following? Do you know this thing?
Yes, sir.
So what will be this? Exactly in the reverse order, right?
Yes, sir.
So when they ask you represent a in terms of upper regular, so what you will write? Exactly reverse, right? Yes, guys. Is it clear?
Yes, sir.
If you find any kind of difficulty, please let me know. Right? Okay, so this much is clear now. Okay, so uh,
Sir, should we write inverse above it or just writing the matrix like the order is enough?
writing like inverse on this, okay, means here you cannot write inverse, right? If you write inverse of this, so it will means you can represent in terms of inverse or without inverse, no, right?
Yes,
Not
sir.
getting.
Like in answer, sir, like I was asking about A equal
Answer
to, should we
depends
write
on the
inverse?
option. If you have a option in inverse, you have to write it in terms of inverse, right?
Sir, but we have done inverse here, so should we maintain inverse here or no need, sir?
You can maintain inverse. You can write in the
Got it,
form
sir.
of inverse also, no? Now you know
Yes, sir.
both the things,
Got it, sir. Got it.
right? Okay. So this is clear. So yes, guys. What else you have studied in this vector space, subspace, null space? Apart from this, what you have studied in this week? Have you studied anything else apart from this? Yes, anyone?
Sir,
Anyone?
like I've
Yes.
seen orthogonal system is there in our topic, sir, but I've not gone through that.
Okay, orthogonal system. And had you learned about the projections?
Yes, sir, we have it on our syllabus.
Okay, projections, right? What will be the projection of B on X? To find out, want to find out the projection. How will you find out the projection? Right? You must have learned this thing. So in terms of formula, if we try to write, it will be like this, right? Are you following, guys?
Yes, sir.
Now, if I want to find projection of any vector on any other vector, not this projection, this is orthogonal projection, right? I want to find a simple projection, like if I want to find projection of u1 bar on u2 bar. So how will you find? So say we take the example, say we have u1 bar is equal to 311. Okay, you have u1 bar is 311, u2 bar is -121, and say y bar is 231, and I want to find projection of y bar on u1 bar and y bar on u2 bar. Okay, so how you find a projection of y bar on u1 bar. We will find it as, right? So what will, sorry, what will be the dot product of y1 bar? Do you know the dot product thing, right? If we have one vector a bar and other vector b bar, so what is the dot product of this? What is the dot product a bar dot b bar? Yes, anyone?
mod of A and mod of P into cos theta, sir.
Okay, and in other terms,
A1 B1 plus
yes,
A2 B2
right? This thing you know. So, what will be the y bar dot u1 bar? We are finding out y projection on u1, right? Are you getting my voice?
Yes, sir.
Yes, sir.
Okay. What u y bar dot u1 bar? What will be the value? You will simply multiply this thing, right? 6, 3, and 1, right? So 6 plus 3 plus 1. What is 6 plus 3 plus 1? 6 plus 3
10.
plus 1?
10.
Yes.
10, sir.
What? Hello.
Yes, sir.
What will be the this y bar dot u1 bar? Yes. Anyone? Chandan?
Sir, should we add the terms of matrix, sir? 2 plus 3 and 1 plus 3 and 1 plus
Yes, yes,
1, 1.
yes. So
Okay, sir. Fine.
6 plus 3 plus 1 is 10, right? And u1 bar dot u1 bar? What do you mean by u1 bar dot u1 bar?
Square of it, sir.
Yes. What is the difference between the length of the vector u1 bar and u1 bar dot u1 bar? Yes. What is the difference between u1 bar dot u1 bar and length of the vector? Are these two things different? Sumukha,
I don't know.
can you increase your voice?
Hello.
Yes. Are the length of the vector u1 bar and u1 bar dot u1 bar are different?
No, sir.
Yes, Chandan. Do you think those two things are different?
Sir, no idea on that, sir.
Okay. See, whenever you multiply your dot product take with itself. Okay. See, u1 bar dot u1 bar. It is same as your length. Length is denoted by this norm. This is called norm. Okay. This thing is called norm. So this square norm, you get the length of vector. So length of the vector is say u1 bar if it is a1I plus a2j plus a3k, then length of the vector will be a1 square plus a2 square plus a3 square. Okay. So what is the sorry, square root. Okay. So this is the length of the vector. Okay. So if you take square root of this is the only difference you will find between the length of the vector and u1 bar dot u1 bar. Okay. So here u1 bar dot u1 bar, you are getting the things right.
Yes, sir.
Okay. So u1 bar dot u1 bar is what? It's 11, right? It is 11, right?
Yes, sir.
So what will be the value now? Projection of y bar on u1 bar, right? Correct?
Yes, sir.
Okay, yeah, whatever I have taught you now, is it clear?
Clear, sir.
Do you have any difficulty in understanding this?
No, sir. Sir, is there any theoretical definition saying about length of the vector, sir?
This is actually the definition, but I will tell you in more detailed manner in the next week's this session. Is it fine?
Okay, sir. Fine, sir. Fine, sir.
Are you guys finding difficulty in hearing my voice?
No, sir. The concepts are getting much clearer, sir. Like we don't have getting any issue from that side, sir. Even though there is some sounds coming up,
Uh,
but no issue from there, sir.
because actually this phase is going on, no, that's why even I am finding difficulty explaining these things.
Thank you, sir. It took time for this.
No, no, this is our duty. We don't have choice. So, okay, what if I tell you if u1 bar and u2 bar are orthogonal? So, what does it mean? What does it mean?
that they are perpendicular.
Yeah, that is perpendicular in terms of maths, mathematically. You told now this u1 bar as u2 bar will be this, right? Theta is what?
Angle
Angle
between
between those two.
Angle between the u1 and u2, right? So in orthogonal, that is perpendicular. So what will be the theta?
90.
90, sir.
So u1 bar dot u2 bar will be 0 for orthogonal vectors,
Yes, sir.
right? So when I say u1 bar and u2 bar are orthogonal, so what you will check? Whether u1 bar dot u2 bar is 0, right? And if they are also orthonormal, what do you mean by orthonormal?
Parallel, sir.
Huh?
I mean, parallel to each other.
No, 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 no. Orthonormal is orthogonal only. But orthonormal means orthogonal plus its magnitude is also 1. So,
Yes,
if
sir.
a vector is orthonormal, that means un bar dot un bar means its dot product with itself will be 1. This is the meaning of orthonormal. This is the meaning of orthogonal. Okay?
Sir, but in orthonormal also, if it's those are perpendicular to each other, then it should be zero, no, sir. U1
No, no,
into, I
no.
guess the,
Means
yes, sir.
like magnitude is 1 with itself.
Okay, sir. Got it.
When we say whether the particular vector is orthogonal or not with other vector, we don't consider the vector itself whether means you cannot say you means whether you never check a particular vector is orthogonal with itself. Can it possible? Can you check that thing? Hello.
Sir, could you repeat once again, sir, what you told?
If you have u1 vector and you're trying to find out whether it is orthogonal with itself, why you will find that?
Sir, since theta itself becomes zero, so
But there should be other vector, no? That is the same vector.
got it.
If you are why you will find if say I am the u1 vector, why I will find I am perpendicular with myself?
Yes, sir. Got it. So theta becomes zero, so sir,
Yeah,
at that
that
point.
means his magnitude is 1 actually. That's what I'm trying to say. This length, this represent the length, no? Length also. If you take square root of 1, that is 1, right?
Yes, sir.
So you can say if all three, u1, all three, this all two, u1 and u2 are following this thing, then it is the set of orthonormal vectors and are orthogonal to each other. Okay, if you have given u1 bar and u2 bar, so these are orthogonal to each other and form set of orthonormal vectors if each has length 1. Is it clear?
Yes, sir.
Yes, sir.
So I will take one problem and you will check whether that is these two things are there. Yes, you just tell me whether all these three vector are orthogonal to each other and whether all of these three form set of orthonormal vectors. So first what you will check? You check is 0, 0 and this is 0, right? So check whether it is 0 or not. So u1 bar dot u2 bar, what you will find? It is 0, right? Is it 0? Correct?
Yes, sir.
Same thing do with this. What you will get? Right? So even if you check with this thing, sorry, you will get the value 0. Check, you will get 1 minus 8 plus 7. It will be also 0. So this is orthogonal basis to the real values. Okay? Is it clear? Is it clear?
Yes, sir.
Okay. Now check with whether those are orthonormal. So we will check for this. Yes. Just do the square of each term. Okay. So okay, you have to take a length, no? 1 bar dot u 1 bar. Actually, it should come 1. Okay. Okay, we will do this in the next class. Okay, but the concept is clear, right?
Yes, sir.
So, what I will do, uh, I will just go through it once again. Okay, and I will let you know about the orthonormal in more clear manner. Okay, so we have been taught null space and okay. So now all these things are clear, right?
Yes,
So
sir.
Yes, sir.
please, now this is the time for you to, if you have any doubt in the week 1 sessions, so you can please ask, because it is now time to solve your doubts.
Sir, by nature, every vector is orthonormal itself, no, sir.
No,
Sir, they are always existent to themselves, no, sir. And I mean, they
not
are units.
existent. Orthonormal you need that magnitude should be 1.
Yes, sir. Got it.
It's- Actually, I will go through these projection things also once again to make it more clear. Okay, there are a lot of voice actually. So I will simply stop these things now. Okay. So do you guys have any doubt?
No, sir.
You guys have any doubt? No. Uh, so uh, in assignments, when you are going to do the assignment
Deadline is given at 8, I guess, sir. So we'll be
for
doing
week
before
one?
that time. Week 1 also 8, sir.
Okay. You have you guys completed the assignment 1?
Not yet, sir.
Okay. One more, we can also take some concepts like okay, number of free variables and number of linearly independent variables is same, right? That is n minus r, right? You guys, I have written. Have you followed that thing,
Yes, sir.
right? So your what you say? Hmm, what we can take now? Uh, we can take. I can give you one homework problem. Okay, you just do this thing. Okay, you just do this homework problem. Okay, and uh, so take this homework problem. There is only one problem, and it is not like it. You will take hardly 5 minutes to do complete it. And if you don't find the answer, I will solve it in the next week. Okay. Okay. Fine. It is very simple, right? You know what to do, right? Can you do this thing?
Yes, sir.
Yes, sir.
Okay. Uh, then mm, You know the number of possible permutation matrices for order 5, right? 5 factorial, correct? If I
Yes,
have
sir.
order 5, then you will take 5 factorial permutations, right? Permutation. It's combination of permutation matrix, right? Uh, then, okay, one more concept. Dimension of column space A and dimension of null space A. What does it form? Dimension of entire vector space. Okay. If I am telling you, if I am asking you this is how many dimension of vector space? In this is vector space in two dimension for belonging to real values. Okay. Now, if I write A as this, so if I ask you what is the uh, number of independent vectors, can you just simply by saying, can you tell me and the dimension of vector space? Both are the same thing. Okay, so I am explaining you, if this is x1, x2 and x3. Okay, so x3 you can get by x1 plus x2, correct? Are you following?
Yes, sir.
So you can express x3 as a combination of x1 and x2, right? So
Yes, sir.
there are two independent and this is dependent one, right? Two independent, right? And this is dependent one. Are you following? Yes.
Yes, sir.
Okay, if this is clear, so this will be two dimensional and this is two, right? Are you is it clear?
Got it, sir.
Okay, so if there is any linear combination, till the linear combination it is fine. If all of three doesn't have, then it would have been vector space of 3D. Like if I change this to, so it would have been 3D vector space. All are independent because what is vectors other definition of vector space? Column spaces, all column spaces should be linearly independent, right? Right.
Yes, sir.
So what I will suggest you, you just go through these concepts once again. Okay, the whatever we have done today, it will be shared with you. Okay, and YouTube link will also be shared with you. Okay, if you find any difficulty, you just means you just ask it in the next week. Okay, so for now, this is it's like we are done with this week's problems. Okay, so So if you have any doubt, we can discuss, or else we can leave. Yes.
Okay, sir.
Do you have Sumukha any doubt?
No, no,
Perumal Swami, do you have any doubt? Yes. Chandan, do you have?
No, sir.
Okay. Thank you, guys. We will meet on the next week. Okay, with the next week's problems. Okay. You just ask me if you have any doubt in the next week. Okay.
okay, sir. Thanks.
Okay. Okay.
Thank you,
Thank you,
sir.
guys. Thank you, guys.